So you can see my format for the data is a little bit different to what you've got for your species index. I've just got some generic names here as I work through creating my formulas. Now the first thing we're going to need for all of our data is to have a total count for each species, so like a total of all the species that we see. So let me just fill that formula across. So I've just added up the total number of observations, and that's something that we're going to need later. I might also know that we're going to need later the average, so let's calculate the average now. In fact, that's come up for me, and let me just select that, and you'll see that I don't really even need to fill in the brackets at the end, and I'm just going to drag that all the way across. And the last thing I'm going to do, even though it's not really asked for here, is that we're starting to look at measures of dispersion. So standard deviation, and we want the sample standard deviation, which is the what I've got here, and it's going to give me the standard deviation for that set. So what I can see across here is I see that the actual counts for each of these species have actually fallen quite a bit over time. So that's the first thing that I observe when I look at this. Whether we look at the total or the average, you can see that it's gone down quite a bit, and the dispersion has also fallen. The standard deviation has fallen through time, and that may be because we're getting towards zero, and once we head towards zero, there's not really much room for variation, is there? Everything's at zero, there's nothing going on. So I think that that's probably why we're seeing this fall in the standard deviation. The next thing we need to do is to get our proportions. So our formula requires our proportions. So what we want to have there is the proportion of the species divided by the total. Now one thing about that is that we want to be able to use formulas. So if I hit F4, what we know is that that's going to lock the cell. But if I hit F4 again, you can see that it's moved the dollar sign just to the number in front of the 14, and it's removed it from the B. And if I hit F4 again, you can see it puts it at the B and removes it from the 14. So one more time and it goes off. Again, it puts both of them there. Hit F4 one more time and it's just got the dollar sign in front of the 14. Now if we think about that, what that means is it's going to hold the cell reference fixed at 14, but it's going to let the column reference move freely. Whoops, I've cooked that. So let me just click on the total again, hit F4 twice, and hit enter. And it says that my share for the proportion here is 0.67. Now let me just drag that down, fill it all the way down, and we can see my proportions are there. And if I just drag my formula across, it's going to fill out nicely for me. Now if I just look up here, you can see what's happened with the way I've applied that formula. It's moving for the blue cell, it's just moving all the way across. For the red cell, it's moved across, but it's still at 14. So that's actually what we want. And if we look down here at the bottom cell, you can see the way it's filled off. The blue cell with no dollar sign restrictions has moved down to the bottom, and the F4 is being held constant there. So I think that by doing that, we've been able to fill out our formula very, very quickly. And if we want to just check, so the shares should add up to 1. So if they add up to 1, let's sum all of those up. And we can see, yes, that they do add up to 1. And let's move across, and we can see that they all do add up to 1. So it looks like my proportions have worked. Now I'm just going to scroll across a bit here. So we've got the 2 bits that we need. So these are my index values. So I need the elements of that. So the formula for that is just the proportion times the log of the proportion. So we click on that cell again, and there we go, and it says it's minus 0.82. We don't really know what that means. We don't have to know what that means. I fill down and I just check what's happened here, and I can see, yes, it's applying my formula. And if I'm just going to be able to select all of those, drag that all the way across, and that's going to give me my values. Now my index formula, or the Shannon-Werner index formula, is the sum of that. So we want equals the sum, and it's actually not quite the sum, is it? It's the sum times minus 1. So let's now put in the minus 1, and you can see that if we do that, we just fill across. Now the issue that we said, and that's something popping up on my screen, the issue that we said was that this scale could be anything. So we wanted a relative diversity index, and we needed the total number of observations for that. Now when you've got words, count just won't work. So if I was to do count up how many cells, now this is pretty easy. We know that I've got 10, but in in your word, their words, their names. So it says the count is 0. So when we've got words, we can't really apply the count function, but actually we can apply the count if function. So this is a little trick. So if we go count if, and then I put in the range. Now remember, we want the range to be fixed. So let's fix that now. F4, so we want it to always use that range, and we use what's called a wildcard, which is just the asterisk sign. And what that says is it says count any text. So I'm going to click OK for that, and you can see that it's counted 10, and that's how many species we have. And I'm now going to fill that across, and you can see what's happening because I've fixed the cell references. It's reading in the right spot. So let me just drag that across one more time. And we actually need the log of that. So we want the log of the total number of counts, which is 235, and we're just going to drag that across. You could use Control R to drag that across, and now we want to get our relative index value. So what's our relative index value? It's simply the actual Shannon-Werner index value divided by the maximum value. And you can see what that's done is it gives us a value that's going to be bounded by 0 and 1. And that's very useful for us in trying to convey something, because if we'd used log base 10, we would get different numbers up here, or log base 2, we would get different numbers from there. So that's the first part on this, the mechanics of calculating your relative diversity indices.